Okay, so we are going to start paper 5-2, October number 2022. Let's start with the question number 1. Calcium hydroxide is slightly soluble in water. And if I think you remember that the solubility of group 2 hydroxide increases down the group. So aqueous calcium hydroxide is also known as lime water. A student measures the concentration of saturated aqueous calcium hydroxide using the following method. Okay, so in this first question, the experiment is the objective is to measure the concentration of the saturated aqueous hydroxide solution concentration. Okay, now this is the method over here. In step 1, add a spatula measure of solid calcium hydroxide to 250 centimeter cube of a distilled water in a conical flask. Stopper the flask and shake the flask thoroughly. So make sure that all of the calcium hydroxide dissolves. Leave the flask stoppered for 24 hours. Okay. Now in step 3, filter the aqueous calcium hydroxide into a clean dry beaker. So the remaining amount of calcium hydroxide that isn't dissolved is actually removed after the filtration. Then from that beaker, what they did that they transfer the 25 centimeter cube of aqueous calcium hydroxide into a clean conical flask. Okay. So initially, the solution is made having a 250 centimeter cube amount, and from that 250 centimeter cube amount, we have took 25 centimeter cube of calcium hydroxide solution in a conical flask. Carry out titration with 0.1 mole per dm cube hydrochloric acid. Okay, so it means that hydrochloric acid must be placed in a burette, right? Now, record the volume of hydrochloric acid required to react with aqueous calcium hydroxide. Okay, then we have noted down the volume of hydrochloric acid that was used for the endpoint. Suggest why it is necessary for the flask to remain stoppered in step 2. Yes, can anybody answer?
To stop loss as water vapors.
For the
So the
solution to
carbon
remain
dioxide
saturated.
doesn't.
Yes.
सर ताकि
The thing is
solution
that
saturated रहे.
no,
lime water turns milky due to CO2.
yeah, because we are dissolving the calcium hydroxide, which is alkaline, and in air we have a carbon dioxide gas, and that carbon dioxide can react with the hydroxide ions to form hydrogen carbonate ions. So if the carbon dioxide gets entered in the or gets in contact with the water, it gets dissolved in it. Okay, so to prevent that dissolving of a carbon dioxide, we have to keep the stopper. Is this clear?
Yes, sir.
Yes, sir. Okay. So to prevent carbon dioxide dissolved in flask. Is this clear to everyone? Okay. And it is because that carbon dioxide is acidic and our solution contains a base or an alkali in it. That's why we have to keep them separated with each other. Okay. Now, next part. Suggest why the student leaves the solution for 24 hours in step 2. Okay. Yes, why is it so?
Calcium hydroxide is sparingly soluble.
Yeah,
So
calcium
the reaction goes
hydroxide
to completion.
sparingly soluble, yes, to make sure that the solution actually gets saturated, that all of the calcium hydroxide that is going to be dissolved gets dissolved completely in it. So we can say that to make sure that all of calcium hydroxide gets dissolved. So the solution becomes concentrated. Oh, sorry. So the solution becomes saturated. Okay. Now, B1, the student finds that the mean titer is 10.65 centimeter cube and the equation for the reaction is shown. Okay, so it means that mean titer is the one which we obtain after taking the average value, after taking the average from the concordant readings that we have performed after the titrations. So here we have an equation. Calculate the number of moles of calcium hydroxide that reacted. Okay. So here we are provided with the concentration of acid, right? And here we are provided with the volume of acid. So we know the concentration and the volume of acid, and they are asking you to find the moles of calcium hydroxide, which is base. So if we are able to find the moles of acid, then we can easily identify the moles of calcium hydroxide. So first we will find the moles of acid, which is equals to concentration of acid times volume of acid. 1 minute. Yes, titer is the amount of acid added, because titer is the volume that is being used in the constant in the titration. Then divided by 1000, as our volume provided is in centimeter cube. So the moles of hydrochloric acid are 0.100 multiplied by 10.65 divided by 1000. Okay, so can anybody calculate and tell me the number of moles of acid used?
One point not 65 into 10 power minus 3.
1 point.
0.065 exponent minus 3.
Okay. 1 minute, please.
I'm getting 0.35, not 6.5.
Do it again because it's a 6 over here, so it must be 6.5, Ahmad.
Right, okay. I took 3.5.
So 1.065.
Record.
Is it 1.065 exponent minus 3?
Yes, sir.
Okay. So these are the moles of HCl that we have found. If we look in the equation, there are 2 moles of acid reacting with 1 mole of calcium hydroxide. So we can take that ratio that the hydrochloric acid is to calcium hydroxide, which is 2:1. So 1.065 exponent minus 3. If these are the moles of HCl, then the moles of calcium hydroxide used must be X, and X must be equal to 1.065 exponent minus 3 into 1 over 2. So we have to half it. Can anybody tell me the value, please?
5.3 into 10 to the power minus 4.
Don't tell me two significant figures, remember? Okay.
5.32 into 10 to the power.
Okay. But I'll suggest, see, in this question, you are observing that there are 3 decimal places or 4 significant figures, and here as well. So use the 4 significant figures value. So 5.3, if there is any other value after 2.
No, sir, 5.
Okay, so 5.325 exponent minus 3 are the moles of calcium hydroxide. Is this clear to everyone?
Minus 4.
Okay, thank you. So 5.325 exponent minus 4 moles of calcium hydroxide is being used during the titration or reacted with a hydrochloric acid. Now, they are asking you to calculate the concentration of aqueous calcium hydroxide in gram per centimeter cube. So what volume of calcium hydroxide we have used in the experiment in this titration? Yes,
25 cm cube.
25 centimeter cube. So we can conclude that these 25 centimeter cube of calcium hydroxide actually contains 5.325 exponent minus 4 moles. Is this understandable to everyone? So can I find the concentration of calcium hydroxide? Here the concentration, if you see the unit, it's gram per dm cube. But right now, when I am going to divide the moles with the volume, then I'm going to get moles per dm cube. So I will multiply it with the MR to turn into gram per decimeter cube. So first 5.325 exponent minus 4 moles divided by 25, which is in centimeter cube. So it must be further divided by 1000 to turn into decimeter cube. Can anybody tell me the value, please? Yes.
0.0213.
0.0213, right?
Yes, sir.
Okay. So this is the moles per decimeter cube, right? Now, to turn into a gram per dm cube, I have to multiply this moles per dm cube by the MR of calcium hydroxide. So MR of calcium hydroxide would be 40.1 plus there are 2 hydroxide ions, so 2 oxygens makes it 32 and 2 hydrogens makes it 2. So can anybody solve and tell me the answer, please.
One 1.578.
1.578. That's it. One point five seven eight. Okay. So this is how you turn mole per dm cube into gram per dm cube. If anybody have any confusion in this calculation, do ask, please.
सर इसमें आपने टाइम्स बाय एमआर क्यों किया?
What I have to find?
ग्राम पर डीएम क्यूब.
Gram per dm cube. And here what I have found? Mole per dm cube. If you consider that the dm cube thing is a constant, so whenever there are moles and you have to turn into mass, you have to divide moles by, so you have to multiply moles by mr to obtain grams. Yes, Soleha?
Okay, sir.
So whenever there is a mole per dm cube, and if I multiply it with the mr, then the answer that I get is actually grams per dm cube. Okay.
Okay, sir. Thank you.
Now, part 3. In a chemistry data book, the student found the value for the concentration of a saturated solution of calcium hydroxide at 293 Kelvin to be higher than the value calculated in B2. Okay. So, according to the data book, what they have discovered that the concentration of saturated solution of calcium hydroxide must be greater than this value that we have obtained. Okay. Now, what they are asking, give 2 reasons why the data booklet value is higher than the value calculated in B2. Okay. Assume the student recorded all volumes correctly. So it means there is no, error in measuring the volume. Carried out titration accurately. So there is no error in the method or in the performance. And recorded concordant titers accurately. Okay. So if these 3 things are correct and they have performed without any error, then why the concentration is actually lower than the actual one? Give 2 reasons. So they said that this actually the value is at 293 Kelvin, right? So one reason can only be that there is might be a possibility that when the calcium hydroxide is dissolved, the student didn't able to maintain the temperature, right? So the temperature of the solution is actually different from this 293 Kelvin. Is this understandable? Because they in the whole method they didn't mention that at what temperature they have performing the reaction, right? Or they are performing the experiment. So one reason can be that the temperature of the solution is different than 293 Kelvin. Is this point is clear to everyone?
Yes, sir.
Now, what can be the other reason? What we did, if you see this part, that we leave the solution for 24 hours, and why we did it, we have answered over here. What is the reason that we leave it the solution for 24 hours? We want all of the calcium hydroxide to be dissolved in water, right? So there is might be a possibility that 24 hours is not a sufficient time that all of the calcium hydroxide gets dissolved. So that can be a second or the other reason for this question. And we can say that 24 hours are not enough to prepare saturated solution. Are these points clear to everyone?
Yes, sir.
Okay. Now, part C. A second student carried out the experiment but did not filter their solution correctly in step 3. Okay. Leaving some undissolved calcium hydroxide suspended in the solution. Predict and explain how this would affect the titer obtained in the experiment. Yes. Can anyone comment on this? That it means that there is some of the undissolved solid is there in the solution, and then the student perform the titration. So how it affect the titer? And when they say titer, so they are talking about the volume that we are
It would be
obtained at the.
higher.
Okay, good, Mariam. But why it would be higher? You have to explain as well. So why
Yes,
it
sir.
would be?
जो
That means it
solution
becomes the
concentration higher हो जाएगी तो इस वजह से ज्यादा मोल्स ऑफ HCl चाहिए होंगे और HCl की concentration तो सेम रहेगी लेकिन उसका वॉल्यूम फिर ज्यादा हो जाएगा.
Yes, because there is no change in the concentration of HCl, but there are now more number of moles in the solution of calcium hydroxide because there are some undissolved particles which are suspended in the solution. So there are more number of moles, and due to that more number of moles, more HCl would have consumed. So the volume of HCl must be used is going to be a greater, right? So here we can say that 1 minute. The tighter volume gets greater or increased because now there are more number of moles of calcium hydroxide. Is this clear to everyone?
Yes, sir.
Okay. Now, D part. Describe how to prepare exactly 250 centimeter cube of 0.1 mole per dm cube hydrochloric acid from 1 mole per dm cube hydrochloric acid. Include the names and capacities of any suitable apparatus used. Okay, so here what they are saying that they have a one stock solution. Okay, and that stock solution contains HCl and its concentration is 1 mole per dm cube. That is the stock solution. And now you have to prepare another solution, a new solution of HCl, and that new solution have a concentration of 0.100 mole per dm cube. And its volume of the new solution must be 250 centimeter cube. Is the question is understandable to everyone? Yes.
Yes, sir.
So we know the concentration of this solution, but we have to first identify that what volume of this solution must be used to prepare the diluted solution of the hydrochloric acid. If you see this here, the solution is 1 mole per dm cube. So it means that solution is concentrated solution. And here, if you see, the concentration is 0.1 mole per dm cube, which is actually a smaller value than that one. So I can consider it a diluted solution. So whenever we have to prepare a diluted solution from the concentrated solution, what you need to do, you have to figure out the volume of the concentrated solution that is needed to prepare the diluted solution. Okay, because we know the concentration of the concentrated solution. Now I have to figure out that how much volume of concentrated solution is needed, and in that much volume I have to mix it with the distilled water to form the diluted solution. So for that, to we have to use the expression which says that the concentration of a concentrated solution multiplied by volume of the concentrated solution is equals to concentration of the diluted solution multiplied by volume of the diluted solution. This is unknown, and we have know all the rest of the three values. So the concentration of the concentrated solution is 1 mole per dm cube. The volume of the concentrated solution is unknown. The concentration of the diluted solution is 0.100, and the volume of the diluted solution is centimeter cube. So if I make the volume of the concentrated subject, then 0.100 multiplied by 250 centimeter cube divided by 1000 would get me the value of this concentrated solution over here, that how much of this solution is needed.
centimeter cube में कहें तो 25 है, लेकिन dm cube में कहें तो 0.025 है.
Yes, we normally do it in centimeter cube, because the apparatuses that or the glasswares that we have used that we used in the laboratory have a scale of a centimeter cube. Like if you are using burette, it has a maximum value of 50 centimeter cube. When you use pipette, it's a maximum capacity of 25 centimeter cube. In the same way, if you are using a measuring cylinder, or the beakers all have a units in centimeter cube only. Okay. So I have got the volume that 25 centimeter cube of the concentrated solution is needed. Is this clear to everyone? Is this part is clear or not?
Yes, sir.
Okay. So whenever we have to prepare the solution from the stock or the concentrated solution, we normally use one glassware or apparatus in which we prepare it. Its shape is like this, and it is called volumetric flask. Okay. So how much volume of a solution that we are preparing? That the volume of the solution is 250 centimeter cube. So it means we need a volumetric flask of 250 centimeter cube. Okay. We now know that we need 25 centimeter cube of 1 mole per dm cube hydrochloric acid for this. Now let's look at the step. How would you write it? First, you will write that to take the 25 centimeter cube solution for the accurate value, we use pipette. So you would write first that pipette out 25 centimeter cube of 1 mole per dm cube hydrochloric acid. Okay. Yes.
ठीक है सर.
Sorry, I couldn't hear you.
नहीं मतलब I was just about the zero.
You're talking about this, these zeros? Your voice is so lagging. And transfer it to 250 centimeter cube volumetric flask. Okay. And if you see this volumetric flask, normally usually have some mark over here. That mark on the neck is actually indicating that if you fill the volume, if you fill the flask till this volume, then this uh, value is filled, or this volume is obtained. So we have just transferred 250 centimeter cube in a volumetric flask. Now fill it up to the mark with distilled water. Is this clear to everyone?
Yes, sir.
सर
Okay, if anyone have any confusion, do ask.
सर ये आपने डिवाइड बाय 1000 क्यों की है?
Sorry, it's 1.00. I have written wrong. Not 1000. Okay.
Okay, sir.
Now, here we have ended question number 1. Now let's move to question number 2 over here. Sodium thiosulfate Na2S2O3 reacts with excess hydrochloric acid according to the following equation. Okay. The reaction produces sulfur dioxide, which is your product, and which is corrosive and toxic by inhalation. So they have told you the effect of the sulfur dioxide, that it is a corrosive and it is toxic as well. Normally examiner do this thing, and in the later on parts they have asked you that how we can prevent by these effects, what we have to do for that. Okay, so we will discuss it as well. Now, the effect of temperature on the rate of this reaction can be investigated by disappearing cross experiment as follows. Okay, so what happened in the cross experiment? If some of you have done the lab in P3, there is an insert where there is, instead of cross, there is some writing over there. We put a container on it, and then we mixes both the solutions and start the stopwatch, and we just wait till that the writing on the paper disappears from the top. Then we stop the stopwatch and record the time, and then we perform the same experiment thrice or 4 times by adding distilled water and diluting it to see the effect. And here we are going to do it by to check the effect of temperature. So it means we are going to perform the same concentrations by using the same concentrations, but doing at different temperatures. Okay. So now let's look at the steps. Measure 10 centimeter cube of 0.1 mole per dm cube sodium thiosulfate. So it means this is the concentration and this is the volume of sodium thiosulfate, and transfer into a boiling tube. Okay. Into a second boiling tube. Boiling tube is a test tube. It's just like a test tube, but it is a little bigger than the normal test tube, and it is thermally more stable. It is resistant to heat. So normally it is used to heat the reagents during the experiment. So into our second experiment, 10 centimeter cube of 0.5 mole per dm cube hydrochloric acid is transferred. Okay. So we got the volume and concentration of hydrochloric acid as well. Heat both the test tubes in the same water bath. Okay. Place a conical flask on a piece of paper on which is drawn a large X. See over here. And from the here, when you see that all the X's disappeared, then we record the time. Okay. So step 5. When the solutions reach the required temperature, remove them from the water bath, pour the content of both tubes into the conical flask and immediately start a timer. Okay. The X on the paper should be viewed from above the flask as shown in the diagram. You are observing the diagram over here. When the X can no longer be seen due to the formation of solid sulfur, stop the timer. Okay. Repeat the experiment using the same volumes and concentrations of the solution at different temperatures. The method is clear to everyone? Yes?
Yes, sir.
Yes.
Okay. Now, state one precaution that should be taken to reduce the hazard caused by one of the products of the reaction. So as they have told us that it's corrosive and toxic by inhalation, so we have to prevent that gas from inhalation. So what we would do, we would perform it in a fume cupboard. Remember, you can either write fuming hood or you can write fume cupboard. So fume hood, so that the gas escapes from the fume hood to the outside of the lab and the inhalation of that gas would be prevented. Is this clear?
सर ये corrosive है तो gloves भी जरूरी नहीं होंगे?
C, they have, which is corrosive and toxic by inhalation.
तो इसे सिर्फ inhale पे करने पे corrosive और toxic होगा?
Yes, they didn't mention anything about skin.
Okay, sir.
Okay. So use a fume hood. Now, suggest appropriate equipment for measuring the required volumes of sodium thiosulfate and hydrochloric acid stated in the method. Okay.
सर ऐसे
So,
सवाल वॉल्यूम से देख के करते हैं ना कि मतलब कितना वॉल्यूम है उस हिसाब से देंगे इक्विपमेंट
but yeah,
मेजर करने
beside
वाली
this,
चीज
we have to figure it out whose volume is more significant as well. For example, if you read the first line, it is stating that sodium thiosulfate reacts with excess hydrochloric acid, right? So it means that this 10 centimeter cube of hydrochloric acid is actually it's already in excess, right? So it means here, if it's an excess, then accuracy doesn't matter, because if it's a 0.1 centimeter cube less, or it would go 0.1 centimeter cube higher, then it doesn't matter. Is this understandable?
Yes, sir.
So for hydrochloric acid, we can use a less accurate, apparatus, and that less accurate apparatus is usually a measuring cylinder. Because it is already in excess. And here, if you see, sodium thiosulfate reacts with excess hydrochloric acid, which is indicating that it is a limiting reactant. So here, accuracy matters, and we need an accurate 10 centimeter cube of sodium thiosulfate. So for that, what we can use, we have a tap in the burette, and the maximum volume that we can obtain from the burette is 50 centimeter cube. But we can control the volume. If we want to take just 1 centimeter cube, we can take it. If we want just 9.9 centimeter cube, we can also obtain that volume from the burette. So here, that burette is mandatory to use for the limiting reactant or for the excess one. we can use the measuring cylinder because measuring cylinder is not accurate and its accuracy doesn't matter. Is this clear?
Yes, sir.
Okay. So for sodium thiosulfate, we would use burette, and here we can use measuring cylinder. Is this clear to everyone? Yes?
Yes, sir.
Okay, now next part. The student recorded their data in the table. Okay. That these are the temperatures. Then those temperatures are converted in Kelvin. Then here the time which is taken by the cross to disappear. Then for the rate of reaction, we divided the temperature by 1. 1 is divided by the temperature. Then turn this into a Kelvin. Okay. So how could we turn this into a Kelvin inverse? 1 over T Kelvin inverse. Sorry, we have to turn this into a Kelvin. Into Kelvin inverse, it's a Kelvin, and here it's a Kelvin inverse. So we have to divide all of these by 1 to get this value. Okay. So can anybody will solve and tell me the answer?
कितने SF लेंगे?
3 significant figures.
सर एक्सपोनेंट में तो नहीं बताना.
No, it's not necessary.
0.
1 minute. See over here. Here, if you see, these are not in exponent, so there is no need to write in exponent. You can check it from the graph that whether you have to write in the normal form or the standard notations. Okay, yes, what is the value for the first one?
Sir, 0.003 003.
0.003. Yes.
Sir, 0 0.
Please again.
सर इसका बस 2 और 0.00 आगे 2 और 0 क्योंकि वो ग्राफ के अंदर उसके 3 के बाद
Yes.
और 2.
Okay, yes. So for the next one.
0.0031.
31.
Yes, sir.
Okay. Then 0.00.
318 आ रहा है तो सर 32 कर दें.
318. No. Then 0.00.
324.
324. Then 0.00.
333.
333. Okay. Then 0.00.
34.
34. Okay, so 340. Okay. See, they have mentioned that the 3 significant figures. Okay. Now, the activation energy EA of the reaction between sodium thiosulfate and hydrochloric acid can be calculated using the equation shown. Okay. R is 8.3 joules per Kelvin per mole. Plot a graph of 2.303 log 1 over T on y-axis and 1 over T on x-axis. Draw a line of best fit. So they have mentioned that what you have to draw. Okay. So this is on y-axis and this is on x-axis. Okay. So 0.0030 at -2. So And you have to put the crosses. Remember, don't put the dots. So at -2, now, what was the next value? Yes.
Zero point zero three
0.0031
one
and minus 2.6.
And what is the value on y-axis?
Negative 2.6.
2.6.
Yes.
Okay. 2.6, 2.7, 2.8, 2.9. So this would be this value. Okay. Then the next one, please.
318.
318. Okay. And on y-axis?
Negative 3.05.
Negative 3.05.
Yes.
Okay. Then the next value?
324.
324.
3.7.
And 3.0.
3.7.
3.7. Okay, it's 3.5. .7. And then the next value, please.
333.
333. Okay. And on
3.9.
y-axis, it's 3.9. Okay. Then,
340.
okay,
4.25.
4.25. Okay, and what we have to draw? We have to draw the line of best fit. One. It would be like this. Okay. Now, next part. Circle the point on the graph you consider to be most anomalous. Okay. Suggest two possible errors in how the procedure was carried out, which could have caused the anomalous point. Okay. So, if we see the anomalous point, the anomalous point is this. Okay. So, I have circled it. Now, the other thing, I have to find out the two possible errors. So, can anyone suggest me the two possible errors?
Second,
Your voice is lagging. Yes. Yes. Can anyone suggest the two possible errors over here?
The timer wasn't stopped on time, like the stopwatch.
The time, can you repeat, please?
The stopwatch was like turned on after the reaction, turned off after the reaction.
Okay, that is a possibility. So remember one thing, if you see over here, this is always the always the dependent variable, because we are not changing this one, and this is actually depending upon the variable which is on your y-axis, right? Because we are using the different temperatures, right? So this is the one which we are controlling ourselves. So this one is the considered as an independent variable. So one error might be this, that if you see this value is actually lower than the line, which is indicating that the actual temperature where the reaction is performed is lower than the one which is recorded in the data. Is this understandable? If you see on y-axis, sorry, on x-axis, actually this point have to be plotted over here, if, and which is telling me, or which is indicating me, that one possible error is that the temperature at which the reaction is performed is the one which is lower than the temperature that we have recorded. Is this clear?
Yes, sir.
Yes, sir.
Okay. And the other error was that, as Mariam said, let me explain that one as well. First, the temperature at which reaction occurred is lower than the temperature recorded. Now, the next factor, the next error can be, if we look at y-axis, it is the log of the reciprocal of the rate, right? So according to the y-axis, if we look at the line, this can be over here, right? Which is indicating that we have actually took the more time, we recorded the greater time than the time that is actually taken by the, that is
By the
actually
reaction.
by the reaction, or taken by the cross to disappear. So that can be the other possible error. That the time recorded is longer than the actual time taken by the cross to disappear. Is this understandable to everyone? Now, use the graph to determine the gradient of the line of the best fit. State the coordinates of both points you used in your calculation. These must be selected from your line of best fit. Give the gradient to 3 significant figures. First, we have to figure out the coordinates, and then we have to calculate the gradient. Yes. So who is going to do this? Take any two coordinates and tell me those. I'm going to put it over there and then find the gradient. Can I take this one, that minus 25? And on x-axis, it is 0.00309, right? Yes, any other point? This one, which is 0.0031, sorry, 331. And here it is 3.75, right? So we have got the two coordinates, 0.00309 and minus 2.50 and 0.00331 and minus 3.75. Yes, can anybody calculate the gradient and tell me the answer, please? Yes. Yes, please.
Negative 5681.8.
Negative 5681.8.
8.
Okay. Now, use the gradient you have calculated and the equation to calculate activation energy in kilojoule per mole, and the equation to calculate activation energy in kilojoule per mole for the reaction. Give your answer to two significant figures. Okay. So let me write the equation over here. It is 2.303 log 1/T is equals to minus EA let me split it like this. Okay. So if you see, this is your y-axis, right? This is your x-axis. And this EA is actually going to be your gradient. So, and they have provided you the value of R over here, 8.31 kilojoules per Kelvin per mole. Okay. So the activation energy, if I make this activation energy subject, it would be equal to minus No, sorry.
Sir,
1
wouldn't the
minute.
gradient be A over R?
Yeah. EA is not actually the gradient, Ahmed, okay? I can write activation energy is equals to,
सर ग्रेडियंट ई ए ओवर आर होगा.
no. What is a
It
gradient actually? If
it
you
should be A
recall,
over.
no. Gradient is delta y over delta x, right? Right?
Yes.
So just give me a minute, please. It is 2.303 log over 1 over t. Actually, just please give me a minute.
सर मेरे ख्याल से ई ए ओवर आर ही होगा ग्रेडियंट.
No. 1 minute. Here I have discussed this relation. Let me find where it is. Okay, the EA over RT. EA over R is a gradient. Actually, if you see, they are saying that use the gradient you have calculated and the equation to calculate EA. For that, we cannot take gradient as EA over R because EA we have to calculate it.
वो इक्वेशन बनाने के लिए कह रहा था.
सर R को मल्टीप्लाई कर दीजिए ग्रेडियंट में.
Yes, but when we move these two, the T is going to be, if I make the EA subject, then it would be 2.303 log 1 over T times R.
सर हम डायरेक्ट रिलेशन से भी तो कर सकते हैं. माइनस ई ए ओवर आर इक्वल्स ग्रेडियंट. ग्रेडियंट हमारे पास आ गया है. ई ए निकालना है, आर हमारे
Yeah,
पास है,
yeah.
उसकी इक्वेशन बना लेंगे.
Yes, thank you. Thank you. Yes, we can do this way as well. So if you see over here that where it is, yeah. So the gradient is equals to minus EA over R. So minus EA over R is equals to gradient. So EA is equals to minus gradient multiply by R. Okay. So the gradient is minus 5681 times R is 8.31.
सर
And
ग्रेडियंट भी माइनस में है और इससे पहले
is
भी
also
साइन
minus.
माइनस
Yes.
Okay.
Can anybody tell me the answer? And I think it would be written as minus 5680. Yes, can anybody tell me the answer, please?
47209.1.
4720
No, sir, it's again. 47200.
47200.
0.8.
0.8. So we have to write in two significant figures. So it must be written as 47000. Okay.
सर ये किलो जूल में आंसर जूल में आ रहा है.
Yes, the R is in joules. So the answer we are getting is in joules. So divided it, multiply it, divided with 1000 to turns into kilojoule. So it would become 47.2. So which is equals to 47. Is this clear?
Sir, it's important to use the three significant figure for
Yes,
the
see, when
gradient part.
when they have mentioned this, so your answer must be written in 2 over
So
here.
initially we were using the gradient in part 4. So do we have to use the three significant figure one?
Yes, you can use either.
Okay.
Okay. Now, the student repeats the experiment at 60 degrees Celsius, but with a different concentration of sodium thiosulfate. The new student is named solution B. The time taken until X can no longer be seen is 11.52 seconds. Assume no error was made in the timing. Okay. State whether the concentration of solution B is more or less than 0.1 mole per dm cube. So at 60, we are getting the cross is disappearing at 7.39 degrees Celsius. Oh, sorry, 7.39 seconds. And here, the time taken for the disappearance of a cross is 11.52 seconds. So which clearly indicates that the actually it takes a longer time, which means the rate is slower. And if the rate is slower, which means that the concentration is of solution B is less than 0.1 mole per dm cube. Is this clear?
Yes.
The concentration of solution B is less than 0.10 mole per dm cube, as it takes more time. Okay. Now, next part. If it is more appropriate for the values in column C of the table on page 6 to be recorded to the nearest second, suggest one reason for this. Okay. More appropriate for the values in column C of the table on page 6 to be recorded to the nearest second. Where is column C? Here we are taking in seconds, and here they are asking it is more appropriate for the word use in column C of the table on page 6 to be recorded nearest second.
Is it because of human error?
No, we don't use the term human error in chemistry.
All right.
Nearest second. If we are saying nearest second, wouldn't be is 0.001 second? Yes, if it's 0.001 second, then obviously it is a very, it is, we can
More
say
accurate.
that. But how could you do it?
So
How
can we
could a
do it
observer,
for this?
how could the person who is performing the experiment can able to record to this second?
The timer, after 60 seconds, it becomes into 1,000 seconds on the timer.
Yes. Okay, I will check this and then let you guys know about this one. Okay. I will first check it and inform you on the group about this part. Okay, so we'll be continuing this question in the next session. Okay, so take care, everyone. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.